Hi, everyone, and welcome to a new session with Code with Sally. The sessions are running now every Thursday at 12 p.m. Eastern Time. If you missed the previous sessions, I highly recommend to check the YouTube channel. You'll find a big playlist here that has all the videos for the beginner series that we are in. The videos are sorted from oldest to newest, and I'm trying to split them into categories for you now. It's work in progress at the moment, so you can see like everything related to variables together. Here we have the primitive data types only, but I will keep adding to it, so it will have the list, sets, and maps. So if you have like something related to primitive to data types, you go to this playlist. Trying to make it easier, and soon I will launch like a quick blog that explains the playlist, the order of the videos, and what we are covering in each video to make it easier for anyone who's joining. But for now, go back and try to watch what we cover because we keep building on top of it. So for today, we'll continue our topic that we started last week, which is the Apex unit test. Last week, if anyone who missed the session or didn't watch it online, we discussed mainly like what is the importance of unit test, why it's very essential, why the assert of the unit test, or when we are writing the Apex test classes, when we use the assert statements, are very critical and very essential to use, and like an issue that some developers go through, that they focus only on code coverage but not testing. And we tried different scenarios to see how we can test different scenarios, and how with or without having the assert, we can have false positives. So if you missed the previous session, go for it. We explained as well in details the steps to write the Apex class, and we'll write another one today. So if you need a simpler version or an easier example, go for the previous session as well. Today we'll continue like in terms of running test classes like last time, because we tried a simple scenarios for the math utility and its test class. We tried only to run the test class through the developer console. So that's the first thing that we covered last time, and it's related to the topic for today. In general, why we need to run the test classes. We wrote the classes that test an existing code, so we want to run it to make sure that our code is working as expected. And we will cover again and refresh our memory. We want to test positive and negative scenarios to make sure we are covering all our scenarios and edge cases, even in the test classes. That helps you catch the error early, because it can be as early as you are developing the unit test class. So your code didn't move yet, even to QA or for testing. So you can catch if you have any issues, and you can fix it on the spot before moving to the next phase, which is QA. And also it helps you keep an eye on where you are from the code coverage. Again, it's not the essential or like the 100% focus when you write the Apex test classes, but they are working together. If you do proper test classes that cover different scenarios, all the scenarios, positive and negative, that definitely will lead to a higher code coverage. And everyone knows for you to deploy to higher org, especially production, you will have to have minimum 75%. And my advice is usually to try and hit like 80 and 85 minimum, because sometimes surprises happen, especially with environments with the different developers teams, dev teams, because sometimes they have lower orgs separate and then they consolidate in UAT, and we are close to production, and sometimes like the code coverage is a surprise that we are below. So if each team work on increasing that code coverage and increasing the test classes and covering all the scenarios, that will be better. So for how to run the test classes, because that's essential, that's the first part that we covered last time, how we can run it from the developer console. And let me show you again quickly. So you go to developer console in your org, and you can hit click on test, and you click new run, and then you can choose the test class that you want to run, for example. And here in that case, you can choose if you want to run all the methods. You can choose if you're writing a single, like you're writing the division by 0 and you want to focus on testing this and make sure it's running correctly, you can hit only this method and you hit the run and you go to the test tab here and you can see like each test class, test run that you did. Did it succeed or not? And what are the errors, if any? So here we have some failures. So it tells you like what you have as working and what is not working as expected. So for you to fix it. So that's how you can run it from the developer console. And that's what we covered last time. Is it the only way? No. Do you have to know the other ways or not? It's like nice to have. And I like to cover it and give it to you. And the same like when we were talking about SOCO and SOSO, we check together different ways to run the code or the statements. And it's up to you to choose what to use. So the other way is from the Salesforce UI. How can we reach that? So you go to your org and you click on setup. And then you will write here in the search, Apex test execution. That will open for you this view where you can choose what test classes you want to run. So similar in terms of like how it looks, like what you have in the developer console, but it's another way. And again, you can, you can go here and click on it. It shows to you that you have, don't click on the view. The view will take you to the class itself. I clicked it by mistake, but click on math utility test here. It will show for you like which ones passed, which one failed, and what's the failure and which line it failed. So that's another way to do it. The third way that we want to quickly check is the Visual Studio Code. And that's open here, my Visual Studio Code. And I have here the math utility. Let me open math utility test. And I will right click and refresh, retrieve from source to make sure I have the latest. And then you can make the choice, for example, that you want to run test division. So you click on run test here, or you can run all of them. Here I try to run only one. So it will tell you that this one failed, and it will tell you what's the issue or what's the problem with that. You can also run all of them by clicking run all tests for the class. And here it will tell you that 3 test classes ran and 2 of them passed and the third one failed. And here I added something. I will show it to you how to do it, but like I added an extra setting in my Visual Studio Code to show me the code coverage percentage. So that tells me that we have 67 code coverage, and we'll explain code coverage soon together again in this session. And it shows to me which lines didn't get executed. Another thing you can do here, let's say, for example, this one fails. So test division exception. That's the one, sorry. Test division is the one that is failing. So let me do here a breakpoint, and you can debug it. And I can go here to math utility. Let me go here, close those, get this next to it. And I will have here divide numbers. I will have here a breakpoint as well. I can click here debug, and that will help me visualize it step by step, as if, you know, when we were talking about mental debugging, expected to go for line by line and try to assume what's the output and see if it's happening or not. That's the same here. So here it stops. It shows to me that decimal value 1. Here in the local, it's 10. And then I will go one line. It will show me the decimal value 2 is 2. So it will keep here the variables that we can access. And then I will go here and go to step into so I can see the math utility. And it will go to divide number. And I will see here that number 1, I don't see anymore the two variables that we had here, decimal value 1 and 2, because now we are in the context of divide numbers, and those are the variables available locally for this method. So you can see number 1 and number 2, it's 10 and 2. And then I will see number 2, is it equal to 0? The answer is no. So number 2 is not 0. Okay, so it will go here and it's throwing an exception for some reason. That's why it's giving me an error. But I have here the decimal value 2 is not 0. So I have to take it offline, like to check why it's doing that. But like, again, if you do the add numbers, for example, and you go here and test addition, I will add a breakpoint and I can go to the testing and debug. That will take me step by step. You can see it. So I can have here 5 and 10, and I will see step by step. So I have number 1 and number 2, 5 and 10. And then I will go into the add numbers. That takes me to the method that calls add numbers, and it takes 2 parameters because that's what I'm passing. I can see here that we have number 1 and number 2. We created the list, and that will call the second method. When I click step into, it will take me to the second one, which has the list. And I can see that I initialized, I have the list with 5 and 10. The sum is initialized as 0. And then I have the number value. First one is 5 because I'm looping through it. And I can see that the value, like the sum became 5 because I added it. And now the number value, the second value is 2. So you can debug it and go with it and see like, okay, yeah, the sum now is 15. So you can see what's happening and what are the values, and it can help you debug if you have an issue. We can go back and see this. This shouldn't like give an error because we are dividing the numbers, number 1 and 2. 2 is the one that we check if it's 0, and we give an error, and it was working last time. And here we are passing the 10 and 2. But I'm suspecting if it's because it shouldn't be. Did I get latest? 1 second. Let me get latest. I'm suspecting that I'm working on an older version. Yes, that's why. It was giving an exception because we updated in the end of the last session the class in developer console, and we didn't update it here. So that's why it was throwing an exception, because it was going to number 1, and we are passing number 1 value as 10. So it goes here and through the exception. So now if I remove this, because we did that on purpose last time to test a specific scenario where we are expecting a specific error and it's happening, or we are now getting this error, this now should pass. If I do the debug again, it should pass. So the debug helps. It's not really like obvious. Why would you need it with a simple method like here? But see here, the if statement didn't happen. It didn't go through the if, and it went to the division. When we tried to debug it first, it went through here, but it was going through the other exception for the number 1. But because we didn't have the latest, it was not working as expected for us. So make sure always to get latest before working, especially when you are working with different developers. And here, when we get it, like it will work successfully, no issues now. So whenever you're working within a team and you have like a bigger team and a more complex scenario, sometimes you expect something or you understand the code to behave in a certain way and that the output will be a certain value. So the debug here is very useful because it helps you go step by step. And it's the same what we do when I ask you to do it mentally. Because you go line by line, you say, I expect now that this is the value because I set it, you see it. I expect when I call this method that the variables will be set with the order we are passing the parameters. So it's doing the same as if you are doing it mentally, but you are using the computer and you see it line by line. So it's very useful. That's another way to do it by opening like the test class. You can choose to run one by one, run all, or to debug the test classes one by one or all. It's up to you. And that's another way to do it. There is another way to do it in the Visual Studio Code. You can go to, usually you would be on the Explorer here. You can go to this icon. If you hover on it, it says testing. So you click on it, that will open here the list of classes, test classes you have, and the method for each. You can choose to run the green button here next to a single method that you are interested in or a single class, or you can choose to run all the test classes in the org. And then you keep saying like here that it's running and it's not done. And once it's done, you will see the results in the output panel. So once it's done, you can go here to the output panel, scroll down, and you can see what are the test classes and test method that got executed. If you have the setting to be able to see the code coverage in Visual Studio Code, you will see the code coverage, the percentage for each class, and the line of codes that got missed and not covered yet. And then you can see like a summary, how many test method got executed and the test rate versus the failure, the success versus the failure. So that's another way to run the test method and test classes and be able to see the results. Personally, I either use it with the developer console, the way we did it last time, by running one by one or the method I want in the developer console and see it. Or I usually go with Visual Studio Code, the way we did it, that I'm writing a test class. I'm working on it. I run it to make sure it's working as expected. If not, I do the debug and see what's the issue. The other way is that's for automation and more advanced users. You can run a CLI command. I have the command with me, but I feel like it's out of scope for this session. So if anyone is interested that I share with you the CLI, I can run it for you, but I don't want you like to feel overwhelmed by it. But like you can go for the terminal here and write the CLI command and hit the syntax. We are saying that we want to run local test. We want to see the code coverage. We want to see the result in a human format, a human-friendly format. And here it tells me that we ran like those test classes and test methods. And it tells me how long it took to run each of them. Then it gives me like a summary of the code coverage for each class and in the trigger and what are the lines that are not covered. So that's another way to do it. I can share the CLI command that I ran in the chat. But to be honest, like I don't usually use it. I use the Visual Studio Code through the class one by one as I showed to you, or the developer console. But again, this is more for advanced or if you have an automation and you want to execute. So it's good to know that the option exists. The next thing that we keep before moving, sorry, anyone has a question? I don't see a question in the chat. And no hands raised. So I think we are good. So again, this is very basic. but it's good to know that you have options on how to run the different classes and methods, and you choose the way you prefer. I keep saying code coverage, and I'm sure everyone who's in working with development, they keep hearing code coverage as well. So with the code coverage, like what is it, the code coverage? The code coverage is calculate the percentage or measure the percentage of your code that got executed when you are running the test class. So when you run your test class, as you saw here, for example, like when we tried to, this one, when we tried to add numbers, for example, we are calling the add numbers that take two numbers, so it went to this method, executed this line, and that called another method that takes the list of numbers, executed those lines, and returned the sum. So when you run the test class, the code coverage calculates for you, when your tests are running, how many lines of code got executed, or how many lines of codes you covered by your test scenarios, and it gives you a percentage. So that's the definition for it. Why it's important? First of all, because we said like for any deployment, you need 75 code coverage for deployment, always target higher. It ensures the test is like your code is tested properly before moving to production. But in case that you are using assert statements, because I saw a lot of people that they go for that their test classes, for example here, and sometimes they do something like that. Something like that, test methods, and they do like this. And they keep saying, for example, add numbers, and they call add numbers 1 and 2. And there is an extra parameter and another one, a new list of integer, and they pass 1, 2, 3. And then they do like that. Another one for divide, math utility, dot divide numbers, and they do like this. And another one with two numbers, 10 and 2. Or let's remove this because this will cause an exception. So they can do like that. So they keep calling in one method all the methods that they have in their class that they are trying to do testing or coverage for. And maybe they do the subtract as well, something like that. And I see 10 and 2, for example. That can give me, for example, 100% code coverage. Like it may cause that the whole lines of my class here get covered and everything is fine. But is that what we really want to do? The answer is no, because we didn't really test if the addition will return 3, or here it will return 6, or here the division will return 5, or here the subtraction will return 8. So actually, for you to be like, code coverage is important for deployment. Code coverage is important to get the errors only if you write your test class properly. And they are connected. Like the more scenarios you will do, the more line of coverage you will have. Like for example, if I don't have the divide by 0, I won't have any logic in my test class that is testing the exception. So this will always false, and this line will never be covered in my test scenario. So the more scenarios you do, the more code coverage you will have. But I have to keep saying, you have to use the asserts, and you have to make sure that you have tested the output as well. Having here, like calling methods randomly like that, will give you the code coverage, but you are losing the main purpose of it, which is testing properly for your code. It helps you catch untested scenarios only early, and we'll see an example with that. And what does it mean? But simply it means like if you have some sort of like here, my test class here, I check add numbers, divide numbers, divide numbers. So definitely I'm not testing the subtract numbers, for example. So when I run the code, and we'll see together how we can see visually which lines are missing from the code coverage, I will know that I'm missing the subtract numbers. So that will highlight for me, okay, yeah, I have a scenario that I didn't cover. Or if we didn't have the divide by 0, you will see that this line is not covered. So you can detect other scenarios that you didn't think about that you need to cover as well. Any questions so far? Okay, we are good. So let's move on to the next slide. So keynotes, not every line will count to code coverage. Like some lines, even if you have them, the code won't, like when you run your test scenarios, it won't count them that they are covered. And if you don't need to think about covering them. And we'll see what that means. But those are like for system.debug, comments, the test methods themselves, because we have the is-test annotation with them. So we'll see it together. The business logic or any method that do like calculations, utility, creating records, updating records, all of that will count in your code coverage. How to check it? That's what we want to see together now. Let's start like first with the developer calls. So I will do a new run here, and we will use the math utility that we had. I will select here that I want to run all the methods of the math utility. So if I run it here, we always look about like the execution and if it passed or not. So here, this is successful. I have, yeah, let me minimize this. Okay. Yeah. So I can see that it got executed successfully, but I didn't see yet the code coverage. So how you can see it, whenever you run the test classes one by one or all of them, you will see here, it updates the numbers here. So you will look, for example, we did the math utility. I will look into the math utility. Here it tells me that the percentage that I covered is 84%, and I covered 11 lines out of 13. But I don't know up until this point what are those two lines. So I have to click on the math utility or open it. If you open it from the resources, it will open like that. You can, from the code coverage here next to it, you can click and choose either all tests, that means all the methods in the test class, or you can choose one by one. So for example, test division covered those lines. And the test division by 0, for example, you will notice that it went through illegal, versus the test division here went through the return, but not the illegal. But usually you look into all, so you can see like what is missing. And you remember I told you, like, not every line count to code coverage. You'll see that here, the blue means it's covered. So you'll notice that any comments, they are not marked as blue or red. That means it's ignored by the coverage, and we don't count them. Like if we have them or we don't have them, like if you add more comments, you won't have more test coverage or less, and the same for the system.debug. So they are ignored. You will see in red the lines that were not covered. So that tells me, for example, hey, be careful that you tested add number and add numbers, and here the divide numbers with the exception and non-exception, but I didn't test the subtract numbers. So that's why the code coverage, when you check it and when you're working on the test class and you run it and you come to see it, it helps you detect like, okay, I missed this scenario and I have to go through it. Versus like if you have everything covered, you will be fine. So that's one way to do it. Another way you can do it is through Visual Studio Code. And to do in Visual Studio Code, there is a setting we have to enable. So the setting, you go to Code, Settings, and that will open for you the tab here for the settings. And you search for something called Retrieve Test Code Coverage. And that's, you check if you want to see the code coverage in Visual Studio Code, you will click here on the specify whether code coverage results are calculated or not. So you check it like that. If it's not, you won't be able to see the code coverage in Visual Studio Code. And then let's go here, for example, I will run all the tests. And after it's running, you can see the code coverage. First, it shows here that we have 85. It shows the two lines, 26 and 27. To see the lines highlighted, you open the math utility itself, the class that you're trying to test, and you'll see here the three lines. If you hover on it, you will see that it says highlight Apex code coverage. You click on it, and you'll see in green again, those are the lines that got covered by the test classes, the test class that we ran. The commands system.debug are ignored, and it will highlight in red the ones that didn't get executed. So that tells you, again, subtract numbers is not covered yet. So if you are a developer and you are working on your own test class, maybe that will be easier for you to enable it in Salesforce. And you don't have to go back and forth with the developer console. Let me give you the name of it. I wasn't aware of it, to be honest, before preparing for the session. So it's a new thing that I learned. I gave you the name of the setting to search for as well. So that in terms of like how to run the test classes, how to run or check for the code coverage and the importance. Another thing, like, and I keep saying it, everyone will be bored with me saying it, but I saw it like in every single project I worked on. People sometimes care only about the code coverage and just go crazy about covering 100% without testing. So it's not good. It doesn't mean that you have everything working as expected. If I want to give you a quick example, what I mean by that, let's see here. So I have the math utility. If I do here, for example, I can add here, it's not realistic thing that I will multiply by 2 before dividing, but let's say I did that. Someone did that by mistake, and it can happen with more complicated projects, like you are calculating a loan, you are calculating interest, you may have more complicated calculations, prices, discounts, stuff like that. So it's very easy to make a mistake here or there by adding a wrong sign or forgetting a bracket that will give you the right calculation. So if I go to the math utility test now, and let me open it, open resource. I will open it to have it here, but I will run, new run, and I will run the test now. We should have something not executed correct because we changed the value. So here, if I see the test division now, it's failing. If I see the error, it would tell me that the division value should be 5. Actually, it was 10 because I made the 10 multiplied by 2, which is 20, divided by 2, that 10. So it tells me, be careful, this is wrong. So with the assert, that stopped me from proceeding. Okay, what if someone did what I told you that sometimes people do, and here with the division, we are doing the division, they commented the assert because that's what a lot of developers, I saw them doing it. they focus on the coverage, so they do this and they forget about the assert. If I run now the same test class, new run, math utility, executed, and I will run it. Now the test class passed. It tells me that everything is good, and even the division passed. So with the assert, the test division failed. Without the assert, the test division passed. So that's why I keep saying, like, the assert is essential, and it goes hand by hand, like with the code coverage, because it makes sure, okay, you covered everything and you have a lot of lines covered, but you covered and you made sure that they are working as expected. So that's the main thing you have to keep in mind. When you do the code coverage as well, that will lead to you like covering positive scenarios, the expected behavior, the negative scenarios, the error, and the exception handling. And that's something we saw last time, and we'll see it again, maybe either this time if we have time or next time. And it will help you as well with the bulk and testing. Like that's in general, like the having test classes and good code coverage, it will help you to make sure that you have everything covered as well. So any questions so far? Okay. So next time, I will start explaining to you what we are going to do. And we'll see if we have time. Like either you will take it as a homework and we check it next time together, or we'll go through it as well today. So what we want to do is we want to refresh our memory and see it in action. Last time we spoke about like preparing test data preparation, and we said why we want to prepare data. We want to prepare the data because we don't want to rely on the data in the org for testing. Like I don't want to rely that I have an account called ABC that I will query and locate to work with, or I don't want to have a specific contact with specific email that I will try to use. So when you prepare your data, you make sure that your code is isolated and it can work in any org. Because if you rely on existing data, when you move your data from dev to QA, if you don't have this data in QA, it will fail. So the other thing, we want to be independent, like each test class or each test method, you prepare the data that you need for it with the setup you want. It helps you as well, like create data specifically that can lead to either positive scenario or a negative scenario. Like if you're expecting contact without a first name, and that will be a negative scenario. So you can create one for the negative scenario testing that is a contact without the first name. If you expect to have full data, to have a positive scenario, so when you are preparing the data for the positive scenario, create a contact with everything. And the methods we discussed briefly last time, we said like you can create the data in your test class, and that's what we are kind of doing here, because we are doing like decimal value 1, 10, and decimal value 2, because we have a simple scenario here. We are testing in the math utility, but you can imagine that when you are testing a contact trigger, instead of creating decimal 1 and decimal 2, you will be creating contacts or accounting contacts. So preparing the data can be done in the test method as we did so far. And that sometimes is something you have to do, because for each test method, you have specific scenario or specific data you want to do. But sometimes you find yourself repeating, like creating test data over and over again for different methods. And that's why we'll move on to setup test setup method and see how it's working and how it resets the records before each scenario. And finally, we want to encourage you to think about like reusability, because you may be creating account for contact trigger testing, but again, you may need in the future to create account as well for account trigger. So, or for another LWC screen or anything. So you may move to test data factory and how to write it as well. So what we want to do we want to simulate a real life scenario where we'll see together a trigger and its trigger handler. And we want to see together how we can write and progress our testing class from basic and preparing the data in the test methods, and how we can move to test data setup, and how we can move to test data factory, which would be ideal for like code reusability as well. So let me explain to you the trigger as well first. So we have a trigger here that I prepared. It's on the contact. It has before insert, before update, after insert, and after update. And when we spoke about the triggers, we said it's best practice to have the switch. So we have it here, and then we are calling the trigger handler. So our trigger handler for the before insert, what we need to do, or what we are trying to do, is to make sure that we validate that the first name of a contact is not empty before inserting and give an error otherwise. Again, real life scenarios can be more complicated, and this can be done with the validation. We don't need a trigger. Again, the main focus here is how to write test class, and how the Apex test methods can progress from like having the data created in the test method versus like the test setup and so on. So it can be like not realistic for you, but that's not like real life scenario. It's more like an example to see what we can do and achieve. In the after insert and after update, we have a requirement that we created a field on the account called last contact date. And with any contact inserted or updated, we want to update the last contact date on the account. So that's why I created like a private method here, so we don't repeat the code again. And it takes the new contacts, and we are calling it from the after update, or we are calling it from the after insert. It's the same method, but we don't want to repeat the code twice. So we created the private method here. What it does is that it gets the IDs for the accounts, and we get those accounts related to the contacts, and we update the last contact date to be today. So that's all what we are doing here. And we have before update, the requirement for this trigger that I assumed we need is to make sure that once the email is set, you cannot clear it. So that's why, for example, we go get the old contact and we check that the email, if it wasn't null, like that means it was set, you cannot make it null now. You cannot clear it once it was set. So we give an error. So that's the contact trigger and the trigger handler. Today, I think because of the time, we would be able to do the first basic step, which will be writing the test class together and having the data created within the test methods. And next time, we'll take it further with the two extra steps, the test data setup and the test data factory, and continue our discussion with the Apex test scenarios, or what I need like to explain to you. So let's go for the contact trigger test. So for the contact trigger test, I will create first a method to test the before insert. So here, what we did, we have, you remember we said the first thing is the annotation. So we have here the is test, and then we create here a test method. I said handle before insert. We created the contact. We give it a last name. On purpose, I'm missing the first name because I want to test that we have the exception. Then we have the test start test, and that's very useful thing to use, and we'll explain it more next session when to use it. But basically, it just isolates anything here between the start and the stop. In terms of governor limits or limits, it resets them within the start and stop, and we'll see it in depth more next time. But what we are trying here, we are trying to insert, and because it's a negative scenario, we are expecting a try and catch, because we'll catch the exception that we have written for this scenario, because we have a first name missing. And last time we explained together that we have here the assert.fail, because if we reach this line, that means our test class is not working as expected. So we have to intentionally fail it, because we should have went to the catch, because the first name is failing. So if I try to save it here, and let's try it together. New run and contact. So I have only one method now. It passed and it got executed, and you will find that no issues. If I go to the contact trigger handler, you'll find that only the before test now is covered, because we have before insert and after insert, because the trigger order of execution, you'll find that before insert will be executed, and then the after insert as well. So those the only two, but before update and after update, nothing happened. And the same here, like it's not linked to account, so it stopped. And here you will find that we went to the add error, because we didn't have a first name. So that's how we did the first part. So let me go to the second and third. Like we want to have one for the before update as well, and one for the after insert or after update, to update the contact and the account. So here I have the handle before update. Again, we prepared here our data. So first step, we said the annotation. Second step is preparing the data. So here we are preparing the data that we want to try to insert the contact. And here I inserted the contact with an email, and I'm trying to clear the email, because I want to test the scenario that I will have the error that we cannot remove. So that's why I'm trying to remove it. And between the start and stop, this is the code that I'm trying to test, or the action, which in that case would be the update. So I'm trying to update the contact, and I will find that I will have an assert here that it tells me it fails, because I'm expecting, because I'm clearing the email, that will go for the exception here. So that's why I have the assert true. It's true that I have this error message in the error, in the catch. But if we reach the assert.fail here, that means I don't, the code didn't work as expected. The third step here, we have handle after insert and update. We have created account, and we have created a contact, and we are updating, we are inserting the contact, and we are checking like that the last contact date is not null, that it got updated, because we wanted to make sure that the logic of after update, that update the contact, last contact date of the account is working as expected. So again, you'll see the pattern. All of that is not new, like we explained last time how to write it. But the thing that I want to highlight here, you'll notice that in each test method, we are creating contact. We are creating a contact here. We are creating account and contact here. So with more complex scenarios, or more complex data, or more complex projects, you'll find yourself repeating yourself, or repeating the preparation of the data over and over again. Because sometimes as well, in real projects, you will need to create even the user that you will be testing with, because sometimes you want to test that the code will execute as expected if I'm working as an employee versus as a manager. So sometimes you need to create a user as well. You need to prepare account. You have to prepare product or data. So the records creation, if we keep adding it over and over again here, in the test method, that will be very painful because you'll keep repeating it every time. Sometimes people say, okay, why would I care? I can take this copy and just go to the new method and paste it. It will be very painful for you if, for example, one time we decide to add an extra field, an extra required field or something. So if you imagine you have different test classes or even different test method with the same test class, and you want to repeatedly like remove a field or add a field or adjust the value, that will take you to very time consuming and you may go into a lot of issues. So having the data created here in the test method, it works and no issues with that. But with the repetition in real life projects, you will find yourself repeating yourself over and over again, and it's very time consuming. So what we will do next time, we'll try to work with the test setup. Let me give you something to read until next time about the test setup and to see how it's working. And if you can, I will share the code in the Slack after we are done. I will put this link for you as well. I will share with you the code of the trigger and the trigger handler. I want you to read about the test setup and understand how it's working, and try to enhance what we have here in the test class, how we can use the test setup instead of repeating the data generation over and over again. So that's what we will see next time together. The only thing, by the way, you will need to do if you will try to do that, I just created a date field on the account called last contact date, but I'm using account and contact, so standard objects you have access to. So I paste the code for you. You can create this field and take this contact trigger and trigger handler and try to make it better using the test setup based on your understanding from Salesforce documentation. But next time we'll start with solving that. And the other part as well, we'll try working with the test data factory. And again, test data factory, the name seems big, but it's at the end, it's a utility class. And we'll see it together. But assume that you want to have a utility class. We did utility classes a lot together where the methods are static. So create utility methods in your utility class to create the data you want for the test. And we'll see it together how we can use it. So as a homework and practice, maybe try to enhance the test class that we have and for the trigger to use test setup or to use test setup and test data factory. You can use both as well. So and next time, that's what we'll start with. We'll start with those two parts to solve them and see how they work together. And then we'll take it further. What we have next, we'll be discussing bulk testing and the importance of bulk testing. And then we'll talk about positive and negative testing in depth and explain what's the difference and see another example and take it further. And finally, we'll talk about the usage of test.start test and stop test and what it means and the importance for it and how critical it will be for asynchronous testing, even though we didn't explain the asynchronous classes or like batch or scheduler yet, but it's good to know that for testing those will be essential for, but that's not the only use for them. And hopefully by next time we'll be done the test classes. Thank you so much for everyone who attended the session today and for anyone who's watching the session offline. And I will see you next Thursday, same time, 12 p.m. Eastern time. Thank you.